Okay, so lesson 17, equations of, and graphs of polynomial functions. So now we're kind of just putting it all together. There's one like new little thing that we're gonna go through, but other than that, we're just kind of like putting it all together. We're gonna be able to graph polynomial functions. We're gonna be able to look at a graph and then write down what the equation should be. Yeah. So if we look at a polynomial function like this one, and you can see that this one is x plus 2 and then to the power of 3, x minus 1 to the power of 2, and x minus 5, then we can see that the x plus 2 factor really just happens 3 times. Okay, so it's like so that one just shows up as a repeat. The x minus 1 factor shows up 2 times, and the x minus 5 shows up once. Well, those actually have different, like they look different on the graph when we do this. So can you guys see the pattern here that the x plus 2, well, that would have a 0 at x is equal to negative 2, right? Can you see like at negative 2, that'd be that point right there. So this is to the power of 3, and it comes down, it does like a little squiggle right on there and then through. This is called a point of inflection. And inflection is really just a name when something was curving this way, and then it's changed up and started curving the other way. We do this quite a lot, like in calculus. Like there's going to be, we'll do a bunch of that. But for now, we just have to worry about like in this situation. But yeah, that is going to happen. Well, I'll kind of get to it down. I'll break it to you now. So those points of inflection are going to happen with any odd power. So that would happen with to the power of 3 at that point. That would happen to the power of 5, power of 7. You just get that like little inflection point happening there for any one of those. Whenever you have a even exponent, so x minus 1 to the power of 2 or power of 4 or power of 6, anything like that happening like that, what'll happen there is actually going to be called like a tangent point, where right at the x-intercept there, or the 0, it starts like it's going to go through, and then it kicks back and goes the other way. So it doesn't go through the x-axis. Okay, and then the last one, the x minus 5 only happens once. And that would be like in this example. This looks like it's going straight up and down, but this is just the other part of the graph. And this would just go straight through. And that's really it. Those are like the 3 situations. So if there's no exponent, it's going to be straight through. If there's an odd exponent, it's going to be a point of inflection. And if there's an even exponent, it's gonna kick back, right? It's going to be a tangent point. Okay, that's kind of the new thing. These have certain names. So you would say that a 0, or in this function, you would say that x is equal to negative 2 has a multiplicity of 3. And multiplicity is really just looking at the exponent there, right? So multiplicity of 3, you would say that at x is equal to 1, in this case, that thing has a multiplicity of 2. And then this one would have a multiplicity of 1 because it's like an exponent 1 sitting there. Okay, now remember as we get going here too, if I was to solve for some equation, if I was to solve for the y-intercept of my polynomial, that would just be throwing in zeros for all the x's, right? And then figuring out what you get out. This is just like another way of saying the same thing, right? If you threw zeros in for those x's, then the equation would really become all of that in the end if those were numbers. All right, let's do some. So it says for each graph of a polynomial function, determine the least possible degree. Okay, so in this case, let's do A. So the least possible degree of this polynomial function. What do you guys think? Yeah. Yeah, it'll be 3. How'd you know it was 3?
It goes through the x-intercept 3 times.
Yeah, it goes through the x-intercept, or the x-axis 3 times there. But it also would have been 3 if it did this, right? If it went down and then up. So it's that squiggle, right? When it like goes up, down, and then up again. So that would be... Yeah, so that'd be that situation there. Okay, so this is going to be degree 3. And then the next part says, what's the sign of the leading coefficient? So do you guys know what I mean by the sign of the leading coefficient? Here, maybe I'll write it out quick. That'd be like y is equal to, if this function was like, let's say, a times x cubed plus 3x plus 4, it means is this thing negative or is this thing positive? How do you know it's positive? Right. Yeah, it's going to be like a general, it's like sloping upward in that case, right? And that's what we look at with like the odd powers. So if it's power 1, then that's just a straight line like the one I drew. But if it's like 3, 5, 7, then positive would make that thing generally go upward. And if it was negative, then it would generally go downward, right? Okay, so that thing has a sign. Oh, not sing. Sign of A is going to be positive. Okay, the X-Intercepts. X-Intercepts here would be -4, -2, and 2. Our factors would be, so then we know our factors in this case, right, would be x plus 4 times x plus 2 and then x minus 2. Okay, and then the last part here just says the intervals where the function is positive and the intervals where it is negative. So this one will be kind of, like we haven't done much of this, but let's say for the positive one here, then this is really like writing the domain. And we're really saying where is this thing positive? It means where are the y values positive? So that's going to be like from here to there, and then from there to there, right? Those are the intervals. So we're saying what are the x values at those points? So in that case, we would say, okay, just a normal bracket, starts at -4 and goes until -2. And then bracket. Why did I use just a round bracket instead of a square bracket? What about right at the point -4 there? That'd be 0, right? So that's not positive, that's 0. So it has to be greater than -4 in that case. Okay, and then you'd use this symbol. This is union. So it's like this one is going to be unioned with, and then everything else. So then that would be from 2 all the way to infinity. All right, where is it? Negative? Okay, so that's going to be negative infinity to -4. Oop. Okay, so that's going to be down here, by the way. So we're talking about from there to there and then there to there. So negative infinity to -4, and then that's going to be unioned with -2 to 2. All right, let's do B quickly here. I might skip a couple. So B, what do we think for the degree of this one? Yeah, 4. It's got to be 4, right? What it could be, like maybe we don't see one of the squiggles there, but it could be 6, and it could be 8, because sometimes the squiggles are kind of small too, and you don't really see them that well. But it does say what is the least possible degree. So in this case, this would still be 4, yeah. So degree 4. And then the sign. Yeah, the sign here is going to be what? Negative, right? This is like a frowny face with a kind of a smirk, I guess, in this case. You guys, do you see that? This is like an upside down. I don't know. Should be like a frowny face like that, right? But this is a smirk in this case. So that's going to be a negative. And then quickly, let's just do the factors, and I'll call that good. So the factors here are going to be x plus 5 And then x, what's the next one here? Plus 1. And then x minus 4. And am I done? What do you guys think I gotta add to this one? Yeah.
X minus 4 should be squared.
Yeah, this is gonna be squared, right? This is like a kickback term. So this thing you'd say has a multiplicity of 2. This one had a multiplicity of 1 because it goes straight through. Multiplicity of 1, it goes straight through. And then multiplicity of 2 because there was a kickback. If there would have been a squiggle here, like going up, then that would have been a multiplicity of 3. Okay? Alright, so I'm going to move on. So let's draw some of these now. So it says sketch the graph of each polynomial function. So for the most part for us in 30-1, we have to figure out our x-intercepts. That's like a must. Our y-intercept. And then just generally, like, you know, which quadrant it starts in, which quadrant it ends in. And then we can make a rough sketch. So we don't need to figure out, like, you know, where the maximum, like if the graph did this, right? I don't need to find exactly where that thing turns around. That in calculus we do that. That's like a local maximum or local minimum, but we don't do that in 30-1. So for now, just a sketch means find x-intercepts, y-intercepts, and the general shape. So looking at this one now, this thing would have a degree of what? 3, right? This is like an x to the 3 polynomial. Is it positive or negative out front? It's positive, right? So I'm expecting this thing is going to do a general shape like that, right? Okay, but before I do that, let's figure out where our x-intercepts are. So according to this part of it, we'd have an x-intercept at 1. An x-intercept at -2. And an x-intercept at -3. So let's just plot those. So just roughly. So at 1, -2, and -3. All right, so the fact that this thing is a cubic function and it starts down here, right? So our graph would start down there, and it's going to end up here. Okay, so now we can kind of just play a bit of connect the dots. But actually, I forgot the last one. Let's figure out what our y-intercept is, so we can kind of get a bit more information here. So anybody know what the y-intercept would be, just based on looking at this one? Yep. Yeah, it'd be -6. We can tell that because if we threw zeros in for our x's, and then just multiply those together, then we'd have -6. Here, yeah, y is equal to -6 for our y-intercept, so -6, so those would be like roughly down here somewhere. And then let's just kind of connect them. So it goes up. I don't know how high it comes up, but it's just going to go up. And then it's got to come back down again. So it's got to pass through. Oh. And then this one might come down a little lower and then back up again. And there you go. That's our sketch of this graph. And we really should label those things too, right? That you'd have that this was 1, -2, -3, and this was at -6. All right, let's do the next one. So just generally looking at this one, is what degree is this one going to be? This would be x to the power of 2? Yeah, it's got to be 4, right? Because this one's 3 already. So this is like, if I expanded that all out, right, that would be x plus 2, x plus 2, x plus 2. So in total, there'd be x plus 4 here. Or sorry, x to the power of 4, I mean. And negative or positive out front? Negative. All right, so don't write this down, but I'm expecting something like it starts down here, does a little squiggle, and comes down, right? So let's figure out our x-intercepts. So our x-intercepts here are going to be at, what's that one? That's going to be x is equal to -2. Yeah. And this one would be x is equal to 4. So let's plot those. So -2 and 4. Okay, so remember we said this thing was going to start down here and it's going to end down here as well. All right, last little bit. Let's figure out what our y-intercept would be there. So our y-intercept, if I threw 0 into that and 0 into that, that would be y is equal to negative 2 cubed times negative 4, which is equal to 32. Just positive 32. So that's going to be up here, right? My scale won't be going up that nice, but this would be at 32. Okay. What do we know? What do we know about the way it's going to go through negative 2 there?
It's a point of inflection.
Yeah, it's going to be a point of inflection here, right? So this thing should do a little squiggle coming through 2. So this would be something like goes up, like turning this way, and then turns back right there. And then it's going to go up, pass through 32. This doesn't have to be the top. Maybe it passes through, keeps going a little higher, and then back down again. That's a common mistake. A lot of people would just make this like the vertex there, like the top. They just go up here and then like have it turn around right there, and then it's kind of awkward. Oop. So our graphs should be kind of smooth as they're going, right? All right, next one. So this one, we don't have as much information. So what do we know? We know this thing is going to be, well, just out front here, that's like x to the 3, and it's negative. So what quadrant is this starting in, and which one's it ending in? Yeah, it's going to be starting in 2, and it's going to be ending in 4, right? It's going to generally do like one of those, like a swoop downward. Okay, but now, well, I also know the y-intercept here is going to be at negative 4. So we got that one down, because if I just threw zeros in for those, then negative 4 would be our y-intercept. What am I going to have to do here to figure out where my x-intercepts are? We got a factor, right? So that's the skills that we were doing last time. So what should I be thinking if I need to factor this cubic function? Yeah, but we need a number to start with, right? We need a number to actually divide it by. So, yeah, we can do the calculator thing. This one probably won't be so hard though, right? I need some factors that multiply to negative 4. Okay, so there's only a few to try, right? And actually, you know what? We can make this a little easier even. Maybe we shouldn't even do negative 4. We can do this a little bit better. 2, 6, and 4. Those are all even numbers. So what I'm going to do first, let's factor out a negative 2. Just make life a little easier on us. So let's factor out, so negative 2, here y is equal to negative 2 x cubed minus 3x plus 2. And why that made life a little easier is because now I'm only going to factor this part of it, right? I can just kind of forget about that 2 I took out. So now I'm just going to find factors of 2. So our factors here would just be plus or minus 1 and 2, right? So there's only 4 to try here. So if I put in p of 1, sorry. So if I just threw 1 in for this, you end up getting 0. If I throw in p of negative 1, I get negative 8. P of 2 is negative 8. And then p of negative 2 gives me 0. Okay, so what do we know? We know that one of our factors here would be x minus 1, yeah, x minus 1. Because this was 1, like the x value was 1, so like the actual factor is minus 1. And then what about this one? We know that this would be x plus 2. Okay, so I know that this is the case now, right? That this has to, that those are 2 of my factors. Now, probably the easiest way we could do this one, let's actually just write it out with those 2 factors and see if we can just kind of use our common sense to figure out what the last one is. So if I just kind of wrote that out again, so y is equal to, I'm just writing out this one, negative 2, and then the two factors that I know, so x minus 1 and x plus 2, and I know that there has to be one more, like x something, we can kind of piece together what it would be. Do you guys know what it would have to be there? Sorry, I paused it there. It had to equal negative 1. And the reason for it is because they have to equal, he said, positive 2, right? Like if I'm just looking at this part, right, I know that my numbers, like the negative 1 times 2 times whatever this is, has to give me 2. Right? So the only way that that's going to work out is if that's negative 1. You guys are good with that? We could have also said that when it was like in this form, negative 2 times negative 1 times 2 times whatever this is would just have to equal negative 4, right? Like if we were doing the whole thing, either way. But it was actually probably easier just to only look at this part of it and just kind of ignore the 2 when we were doing it there. Okay, what else could we have done if you couldn't figure that one out? What would your next step be here? Yeah, probably synthetic division. It's easier. So just because it's good review, let's do that. So let's start off with our original function there. So, well, actually, let's start off with just, again, this part of it. So we'll go x to the 3 minus 3x plus 2, right? We're just going to factor just this part of it, because that negative 2 I factored out. It didn't really, it doesn't need to play any part now. So if we're going to synthetically divide this, then this would be 1. And then what would my next number be? No. 0. Yeah, good. Because notice this goes from x to the 3 to x. So our x squared term, we do have to include that. So 0. And then negative 3 and then 2. And then we'll try out 1, right, for this one. All right, so we bring 1 down. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Negative 3 plus 1 is negative 2. There's negative 2, so that's 0. Okay. Then what am I going to do? Do it again. Yeah. Okay, well, we'll do it again, but we're going to do it again with these numbers now, right? Because now this is my constant. This is my x term, and this is my x squared term. Okay, so now we'll do it again. But this will be 1, 1, negative 2. And we're going to try out the other one that we know is a factor, so negative 2. We'll bring down our 1. Negative 2 times 1 is negative 2. 1 minus 2 is negative 1. Negative 2 times negative 1 is 2. That's a 0. So this, looking at this one here, is really saying like 1x minus 1 or x minus 1. So there's our last factor. Okay, so either way, here it is. Okay, so our x-intercepts here are at 1 and negative 2. And that's kind of it, right? Okay, so so what's going to happen here? So if this is negative 2 and this is 1, can you guys actually right now, before I do it, I want you guys to try it. And it also goes through negative 4. Okay, so the negative 2 point, is that going to go through? Is that going to squiggle? Or is that going to be a kickback? Straight through, right? The negative 2 one only happens once. So it goes straight through. Okay. And then what about the... Here, I'm going to redo that. Goes down like this, straight through, and let's say it goes up through 4, and then what about this one? What happens here? Yeah, kickback, right? And that's because we could have written this thing with a multiplicity of 2, right? This is the same thing as negative 2 x minus 1 squared x plus 2. Okay, so it would come up, it would kick back, and then come back down again. Okay, so I'm going to skip this question for time's sake here. Moving on down. Okay, let's do this one. So it says Bill is preparing to make an ice sculpture. He has a block of ice that is 3 feet wide, 4 inches high, or sorry, 3 feet wide, 4 feet high, and 5 feet long. Bill wants to reduce the size of the block of ice by removing the same amount from each of the 3 dimensions. He wants to reduce the volume of the block to 24 feet cubed. All right, so let's write a polynomial for this function. So I'm going to use v of x is equal to, and then generally the volume of an object is just the length times the width times the height. And then we're just going to put in our actual factors for that. So we'll say, okay, v of x is, and it says the block was 3 feet by 4 feet by 5 feet. So really that would be it. It'd be 3 times 4 times 5, right? But I'm going to just for a second write it as like 3 times 4 times 5, like that, and just kind of leave a space. Because what are we going to do? We're going to reduce the size of the block by removing the same amount from each of the 3 dimensions. So what's going to happen here? Minus x, right? Minus the amount that we're removing every time. So it'll be 3 minus x, and minus x. There you go. There's our polynomial function for this. Okay, now this is kind of the question that you guys had for your long answer. That it's going to be one like this. So it says how much should he remove from each dimension? Oh, and sorry on the last one, I should have added a little bit more. It was equal to 24, right? Because we want our volume to be equal to 24 in the end. Okay, so when it says how much should he remove from each dimension, what are we wanting to solve for here?
X.
Yeah, we got to solve for x in this situation, right? So is it just, would x be equal to 5, 4, and 3? Like just, no, why is it not? Yeah, it's got to be 0 on the other side, right? That only works, that method of like looking at those factors and figuring out what x is, only works if y is equal to 0. So we pretty much need to do that if we're going to do this thing algebraically. But I just want to kind of show you what this will look like on a graph. So if we were going to graph this thing, what I would do is I would just graph y1 is equal to 24, and y2 is equal to 3 minus x times 4 minus x times 5 minus x. Okay, you would get something that looks like this, right? And what am I looking for here? Yeah, where it crosses, right? So the red line was my y is equal to 24. The blue line was my cubic function there. It's where they cross. So what would my answer be here? Looking at that, if you can see the numbers. 1, right? The x value, right? So what's the x value? It's x is 1 when y is 24, right? The y is where they cross at that point. The y's are the same for both of them. Okay, so you can do it that way. That's pretty straightforward and easy, right? The other way, though, we can do it algebraically. Do you guys want to do this one algebraically? All right, let's do it. So, anybody have any ideas where we're going to start on this? Yeah.
Set the entire equation equal to 0.
Yeah, we do. So let's do this first. I'll try to bring 24 over. So minus 24. So we've got 3 minus x times 4 minus x times 5 minus x minus 24 is equal to 0. That doesn't look much better though, does it? I can't really see what the answer is yet either. You guys kind of see what we're going to have to do here? We're going to have to expand all this. We're going to expand it all and then factor it again. It's kind of our only method. So can you guys take a second? Can you guys expand it all? I'll pause it here. It's going to be good practice. Okay. So if you're just tuning into this, we just kind of showed how you would start to solve this algebraically, but I'm going to move on. So All right, so now let's move on to the next one. If we did this, sorry, we found that the point there when we graphed it was 1, 24, right? So it would have to be 1. So you'd have to remove 1 from every one. So then your dimensions there, well, whatever. We'll just take away 1 foot from every one. That's what we're doing. Okay. Next one says 3 consecutive integers have a product of negative 2, 10. Now write a polynomial function to model this situation. So can you guys, so this is what it is in the end. And to make sense of this, right, if this was our first number, whatever it is, let's say it was 6, then our second number would be 7, right, which you could write as 6 plus 1, right, x plus 1. So that would be like 7, and that would be like 8, right? 6 plus 2 would be 8. Okay? So those aren't the numbers I was just showing you. This is all supposed to equal, or have a product of negative 210. So I'll say is equal to negative 210. Okay, and if we were going to solve this, really all we have to do here, doing it the easy way, we'd graph this as y1 or y2, and we graph this one, and the answer would be where they cross, right? The x value where they cross. So if you do that, we get an intersection of negative 7 comma negative 210. So then our integers would just be negative 7, right? That's what our x value was. And then what would the next one be? Careful with the negatives. Yeah, because it's like negative 7 plus 1, right? So now you're at negative 6, negative 5. You're like getting less negative. You're going to the right. Yeah. Okay. Last one. So we can't, like, up until now, I've been kind of just throwing in my my X-intercepts there. But we can't really just do that. You can't assume that our A value is equal to 1 all the time, right? There's going to be some stretch factor on that. So we've done this a few times now. It's going to be the same method, right? We'll figure out what we can with these ones based on the information. But then very last step, we're going to have to solve for A. So, okay, this one says a polynomial equation has the following 3 roots. So it has a negative 2 is a root with a multiplicity of 1. Okay, so that would be like an x plus 2. What about this one, though? 1/3 is a root with a multiplicity of 2. What would that look like? Yeah. Yeah, and the way we can look at that is we say, okay, well, if we know that x is equal to 1/3, right, then you can kind of work backwards. If we like multiply both sides by 3 here, you could say, okay, well then 3x is equal to 1. And then subtract 1 from both sides. You'd have 3x minus 1 would be equal to 0. And so that's like our factor there. And it says it has a multiplicity of 2, so square at the top there. And then lastly, 1 is a root with a multiplicity of 3, so that would just be x minus 1 to the power of 3. Okay, so we're pretty good. It also tells us that we have a y-intercept at 2/3. So let's write out what we know so far, though. I'll just write that with what we figured out. So p of x is equal to a, and then we'll just write in what we know here. So x plus 2, and then 3x minus 1 squared, and x minus 1 cubed. Okay? Now, if I was going to, I got to figure out what A is. How can I do that? What bit of information did they give us that we can use? Yeah, that we know the y-intercept, right? We know, like, we could solve for A if we just knew what numbers to put in for x and for y, right? It's a good thing that they gave us another point, really, because this y-intercept would be the point 0, 2/3. So there's an x and there's a y. So we'll throw those in, right? So instead of p of x, or instead of y there, we're going to write 2/3 is equal to, and then a times 0 plus 2 times 3 times 0 minus 1 squared times 0 minus 1 cubed. And now I'm just going to simplify that down a little bit. So 2 over 3 is equal to a, and then this just becomes 2, and then negative 1 squared, and then negative 1 cubed. So that would become 2 over 3 is equal to, all of that would end up being negative 2. So negative 2a, we'll call it. So a would be equal to negative 1 over 3. So then we just throw it back in, right? That was our a value, so we can just say p of x is equal to negative 1 over 3, and then all of the different factors that we found. So x plus 2, 3x minus 1 squared, and then x minus 1 cubed.